How's it going, everyone? In today's episode, we'll be working on adding an aim-down sight system to our first-person shooter project. Full disclaimer ahead of time, this is not a fully procedural system, and we'll go over how to create the utility actor to calculate the proper offset vector for aiming down sights. Later on, you'll be able to easily modify this actor for all kinds of different weapons and idle poses, but for now we'll focus on the assets we already have working in Engine. I've created a sight mesh and color map compatible with the procedural weapon material we made in previous episodes, and we'll also briefly touch on UMG and how to create and animate a widget for our reticle. First off, however, we'll need to dig back into our player blueprint to correct some oversights on my part from earlier in the series. So without further ado, let's get started. If you've played around with the work we've completed so far in the series, you may have noticed strange behavior when looking up and down near walls. It appears that our spring arm pivot points are off by some amount, so we'll need to open up our player blueprint to see what's going on. Clicking on mesh root or cam root, you'll notice their pivot points are located at the center of our capsule rather than the camera. The spring arms aren't checking for collision, so the children will just swing right through level geometry if you're in the right position. To fix this, we'll make some adjustments to our actor hierarchy. Mesh root and cam root both need a new Z value of 60. Offset root and cam scale also need to be offset downward by the same amount, so their new Z values are -70 and -60 respectively. Now when we click on mesh root and cam root, you'll see their pivot points are properly centered on the player camera. Last thing we need to do is open our getLookInput vars function and navigate to the end of the pitch offset section. We need to change this A input to a smaller value so we're not offsetting our Viewmodel and camera outside of the bounds of the collision capsule, which currently has a radius of 35. I went with 15 for now, and we can always come back and adjust this further if needed. With those changes in place, the issue is fixed and we can move on to importing and creating the assets we'll need for today's episode. We'll start off by importing SM SightMesh to our Meshes folder, making sure to not create new materials for it. Then import SightMesh Color Map and SightMesh Normal to the Textures folder. Inside the Materials folder, right-click on and create a material instance of M_weapon base, renaming it to MI_SightMesh. Opening it up, swap out the Masks map and Normal texture parameters with the textures we just imported. Inside the SightMesh asset, apply the material instance to the second slot. Back in the Materials folder, create a new material called M_SightHollow. This translucent material doesn't use any textures, but rather a linear gradient and generated band nodes. You can pause the video here to copy the values I've settled with to start, but feel free to adjust them to your own liking. We'll use this new material in the first slot of the sight mesh, and the sight is now ready for use in-game. Back in the Materials folder again, create a new material called M_Red Dot. Make sure to set the material domain to user interface. We're going to use a radial gradient to create a dot with a clear central circle but soft edges for the player's reticle when aiming down sights. You'll also want to make sure the blend mode for this material is set to translucent. Again, you can pause the video here to copy down the values I decided to use. Next, create a new material parameter collection called NPC-FP. Inside it, we'll make a new scalar parameter called FOV, setting the default to 90. We'll also make a new vector parameter called offset, leaving the defaults at 0. Create a new material function called MFFP. In a moment, we'll build this function out to use the NPC's values in any material we need represented in first person. In the Animations folder, create a new float curve asset and name it ADS curve. This is the curve used to drive the transition between our base pose and aiming down sights. Feel free to pause and copy the values in curve shape shown on screen now. Navigating to our SKFP gun asset, we're going to create a new socket called Sight attached to the grip bone. Use the sight mesh as a preview to line up where the sight should rest on the weapon. It's fine if the alignment isn't perfect, as our view will be centered on the pivot point of the sight mesh. Next, I'll be deferring to this awesome tutorial by Jack French on creating a material that allows for custom field of view and prevents clipping by using world position offset. I won't be going over how to recreate his code in my video, but instead we'll be utilizing his method inside a material function that we can reuse across whatever materials we need to have shown in a first-person view. You can see here I've migrated his code almost one-to-one into MFFP, the material function we created earlier. We're using our NPC-FP material parameter collection at the beginning to control the offset of those first-person meshes, and up in the FOV section to control the custom field of view of those same meshes. Now we'll go through and add a new static switch parameter called FP to any materials we need represented in first person, starting with M_weapon base. The false input will just use 0, but the true input will use our material function MFFP. Plug the output of the switch into the world position offset pin of the material. Now on any instance of this material, such as MI Sight Mesh, you'll see a new boolean you can enable called FP?. If you need a version for third person and first person, duplicate the material instance and add the suffix FP. On this duplicate, simply enable the FP boolean and you'll be ready to use it in first person. You'll know it's working when the thumbnail for the material changes to a smaller sphere. As a side note, the built-in material for the mannequin arms will require a slightly different setup. Locate m_UE4 man_body, and before the final node, add a set material attributes node with a pin exposed for world position offset. Now you're free to recreate our static switch parameter method here too. After that's done, create two instances of this material called MI player model and MI player model FP, with the latter having that FP boolean enabled. Next, we'll need to head back into our weapon assets and make some adjustments. Starting with weapon base, change materials variable type to a material instance and replace the default with MI weapon base FP. Increase the bound scale of the weapon mesh to 2 to prevent visual errors in certain edge cases with our new first-person material function. Now we'll add a new boolean variable called reloading so we don't have to cast to a specific child of our weapon class to determine whether or not it's currently reloading. Then add a new vector variable called ADS offset, leaving the defaults at 0. We'll create the utility actor to find this vector's value shortly. While on the topic, head over to first-person character briefly to create a vector variable of the same name here. Then, back in weapon base, use the equip event to set the player character's version of ADS offset using the weapons. Back in first-person character, add a begin play event and use getWeapon to call equip. Finally, open up weapon basic rifle. We'll need to go through and replace all references to the local reloading boolean with the one we just made for the parent class. After that's done, you can safely delete the reloading variable from this actor. While we're here, add a new static mesh component to weapon mesh called sight. Set the parent socket to the one named sight we created earlier, set the static mesh to SM sight mesh, and swap out the materials for their first-person counterparts. Disable all collisions on this component, and we'll set the bound scale to 2 here as well. Now we'll start working on the actual aim down sights functionality. Open your project settings and add a new action input called ADS, binding it to the right mouse button. Open up the first-person character blueprint, making sure to swap out the mannequin's material for its first-person version. Navigate to the event graph and add a call to the ADS input we just made. Use getWeapon to check if our gun is not currently reloading, and pass the result into a branch. Add a new timeline component called ADSTL and open it up. Set its length to 1 and enable Use Last Keyframe. Then add a new float track called ADS Alpha. Use the external curve dropdown to select the ADS curve we created earlier, then head back to the event graph. Use the released output of ADS for the reverse input of ADSTL, and add a new custom event called Exit ADS, using its output to drive reverse as well. After the branch, add a set play rate node for ADSTL, connecting the output to play. Add a divide float node for the new rate input, and promote the denominator to a new float variable called ADS speed. This will be the time in seconds it takes to fully enter ADS. Promote the output of ADSTL to a new float variable of the same name, setting it with update. Use this alpha for a new lerp, promoting A to a float variable called FOV base. Promote B to another new float variable called FOV ADS, and set these default values to 90 and 70 respectively. Use the output of this lerp to set the field of view of the character's camera component. We're also going to get the post-process settings of first-person camera, adding a set members in post-process settings node with a vignette intensity pin exposed. Add alert for this input pin using ADS alpha for the alpha, 0.4 for A, and 0.7 for B. Now get a set scalar parameter value node to modify the MPC we created earlier. Set the parameter name to FOV and create a new lerp to use for the parameter value input. We'll again use ADS alpha to drive the alpha of the lerp. Set A to our base FOV value of 90, and set B to a very low number to flatten the view model. In this case, I went with 25. We'll access the MPC again by adding a getVectorParameter value node, this time setting the parameter name to offset. Break the output pin, then add a setVectorParameter value node, again setting the parameter name to offset. Break the input pin, and pass R, G, and A into the get node. For the B input, add a new lerp between 0 and 30, which will offset the view model forward to counteract the zoom effect from using a lower FOV. Use our call to ADS alpha from the previous lerp to drive this one's alpha as well. Jumping over to weapon basic rifle, add a call to our exit ADS event after successfully starting a reload. Playing in the editor now, you'll be able to see that the main functionality for aiming down sights is working as intended. Our field of view is constricting, we get a nice vignette at the edges of the screen, and our view model is flattening down so we can get a clear sight picture without perspective distortion from being super close to the mesh. Next, we'll create a widget to represent the site's reticle center screen. Back in the content browser, add a new folder called HUD. Create a new widget called HUD Red Dot and open it up. Add a new canvas panel to the hierarchy, anchoring it to the center of the widget and setting its size to 90. Then add a new image to the panel, once again centering it, and set its size to 40. Set the image material to m_red dot and tint the image as you like. Rename this image to red dot BG and add another image to the canvas called red dot FG. Set its size to 25 and center it. Again, set its material to m red dot and use a more saturated color for the tint than the previous image. Go back and rename the canvas panel we added to red dot panel, and make sure to tick the size to content and is variable boxes. Over on the graph side of the widget, add a new variable called player ref, setting the type to first person character. Make sure this variable is exposed on spawn so we can set it from the player blueprint. Add the construct event and set a timer to loop 60 times per second. Attach the timer to a new custom event called update reticle. Get ADS alpha from the player ref, normalize it between 0.75 and 1, and clamp the result. Get a reference to the red dot panel to set its render opacity using the output of the clamp. Add 3 new lerps, using the output of the clamp as the alpha for the first 2. For the third, we'll instead be using dip alpha from the player ref variable. Add a set render scale node, splitting the scale input pin. Use the output of the first lerp for both x and y, leaving a at 0, and setting b to 0.65. Now add a set render translation node, again splitting the input pin. Use the second lerp for the x input, setting a to 100 and leaving b at 0. Then set the third lerp's b input to 20, connecting it to the y input of the translation node. Now we have a reticle that will always be dead center in the screen, but will animate in a way that fakes it being attached to the site itself. To put it to use, head back over to the first person character blueprint and after begin play, add a create widget node. Set the class to HUD red dot and use a reference to self for the player ref input. Use the return value to add to player screen, and now we can switch over to game mode to see how it looks. We can see the reticle appearing to grow and slide from the right into view, which is exactly what we want for this sort of weapon. You can adjust the values in the second lerp we made if your weapon's idle pose is oriented in a different way, like Destiny's bows that are held in a downward position. Now we'll actually create the actor that calculates the ADS offset vector for us. Create a new utilities folder inside your BPs folder, and within that, create a new actor called ADS offset calc BP. We'll essentially be recreating the first person portion of our player character's hierarchy within this actor. So start off by adding a skeletal mesh component called Viewmodel. Set the relative Z location to -106, and the relative Z rotation to -90. Set the skeletal mesh to SK mannequin arms, and set the animation mode to use animation asset. Use FP idle as the anim to play, and make sure looping and playing are unticked. Now add a new skeletal mesh to the view model called weapon, zeroing its transforms and setting the parent socket to grip point. Set the skeletal mesh to SK FP gun, and then attach a new static mesh component called sight. Set the parent socket to sight, and the static mesh to SM sight mesh. Now add a camera component called camera, and set its relative Z location to 65. Then add and attach a new scene component called ADS location. This is the actual location we want to be drawing our sights towards, so I've offset it forward by 12 so the sight's not within the camera itself. After all our hierarchies set up properly, add a new variable called offset output, and make sure it's instance editable. Over in the construction script, follow the setup here to get the location of the sight socket on the weapon mesh relative to the ADS location scene component. Invert the X and Z values of the resulting vector, then set the offset output vector using X for Y, Y for X, and Z for Z. This converts the result into the proper axes for the view model's animation blueprint to use. Now all that's left to do is drag and drop this actor anywhere in your level. Notice that the offset output vector in the default section isn't 0 anymore, but rather the actual vector we need to offset the view model by to be fully aiming down sights. Copy this output to your clipboard, then remove the utility actor from your level. Navigate back to Weapon Basic Rifle, and paste the copied vector value into the ADS offset variable. Now all that's left to do is put that vector to work. Open up the first person anim BP and head to the event graph. Get the ADS alpha from the player ref, subtract this value from 1, and promote the output to a new float variable within the AnimBP called ADS alpha. Use this value to lerp between 0.3 and 1, and promote this lerp's output to a new float variable called ADS alpha lerp. The A value of this lerp is the percentage of strength we'll reduce other procedural animations to when aiming down sights, so change it as you need to. Now add a new function called modify for ADS and open it up. Within this function, we'll be adjusting various other values in our AnimBP to accommodate ADS, mostly by reducing the effect of the other procedural animations. If you want to disable one completely, such as the rotation for crouching, use ADS alpha as the multiplier rather than ADS alpha lerp. Back in the event graph, add the new function to the end of the execution line. Finally, get the ADS offset vector from playerref and promote it to a variable within the AnimBP of the same name. Now we'll need to go through and adjust the alpha values for several of our existing transform bone nodes. Weapon sway uses ADS alpha lerp, pitch offset uses ADS alpha, location lag uses ADS alpha lerp, location lag tilt uses ADS alpha lerp, and in-air tilt uses ADS alpha. Back at the beginning of the anim graph, add a new transform bone node and disable the pins for rotation and scale. Set the bone to modify to spine 03, and use 1 minus ADS alpha for the alpha input. Enable interpolation on the alpha, set increasing speed to 15 and decreasing speed to 30. Grab ADS offset and split the output pin, using only Y for this transform node. Make sure the translation mode is set to add to existing, then add another transform bone node. Once again, disable the rotation and scale pins, set the bone to modify to spine 03, and set the translation mode to add to existing. Split the input pin of the translation vector, and use ADS offsets X and Z values for their respective inputs, leaving Y at 0. Use the same 1 minus ADS alpha pin to drive this node's alpha input, and now we're ready for the last step. Find the play FP idle node at the very beginning of the anim graph and add a blend node after it, using it as the B input. Duplicate the play node, set both play rate options to 0, and disable loop animation. Use this as the A input for the blend node, and use ADS alpha as the alpha for the blend node. Reconnect everything together, and now we can check out how we did in-game. Playing in the editor, you'll see we've successfully implemented aim down sights. This effect blends together with all the procedural animation we previously completed, although it's intentionally toned down to account for how close the view model is to the camera. The reticle we made stays dead center in the screen, only moving for the transition to ADS and bobbing slightly when we jump or land. In the next episode, we'll be building on our work earlier in the series by covering some more advanced movement mechanics like sprinting, sliding, and double jumping. I hope today's video helped you out in some way, and keep an eye out for more FPS content coming soon. Until next time.